Good day, everyone, and welcome. In this video lesson, we are going to discuss the qualitative characteristic of image formed by mirrors. Our objective includes determining the qualitative characteristic of images formed by plane and curved mirror, and apply ray diagramming techniques in describing the characteristic and position of images formed by mirrors. Before we proceed with the main lesson, I want you to test yourself by answering the Week 2 pretest in your Google Classroom. You may pause the video now. Welcome back. How did your test go? If you got a perfect score, you can skip this video and continue answering the rest of the learning task. If you made one mistake or more, I would like to ask you to watch the rest of this video. Just a reminder that throughout the lesson, there will be some questions that will be posted or asked. Feel free to pause the video to answer them. You may also try writing your answer on a piece of paper and upload your work on your portfolio. Introduction to mirrors. Now, what comes into your mind when you see a mirror? If you thought of seeing yourself or your reflection, then you are correct, since that is the most common use of a mirror. A mirror has a smooth reflecting surface. They are usually made of polished metal or glass that has been coated with metallic substances. There are two kinds of mirror, the plane mirror and the curved mirror or spherical mirror. You have two types, namely concave and convex. The plane mirror has a flat, reflective surface. This is the common mirror we tend to use when we want to see ourselves. These are some examples of those plane mirrors. The concave mirror is a curved mirror in which the reflective surface bulges away from the light source or object. It is also known as converging mirror because the rays converge or intersect after a focal point after reflecting. As you can see on the picture on the right, we have a light source or object and the mirror bulging away from that light source. The rays, represented by a solid line with an arrowhead, upon reflecting on a mirror, converges to a single point or to the focal point, hence the term converging mirror. The convex mirror is a curved mirror in which the reflective surface bulges towards the light source or object. It is also known as diverging mirror because the rays converge or intersect at a focal point behind the mirror after reflecting. As you can see on the image on the right, we have the object and the mirror bulging towards it. Now, the only difference between the concave and the convex is the bulge of the mirror itself, and also the reflection of the rays. As you can observe, the rays of the convex mirror, once reflected on the surface of the mirror, tends to diverge. But if you look closely, you can see that there is dotted lines that continue to converge behind the mirror. Now, this is only a representation if the rays continue to pass through the mirror. But in reality, it does not, since the light rays are already reflected by the reflecting sides of the mirror. What do you think are the uses for these kinds of mirror? I want you to write your answer, and you can check if you got it correctly on the next or the following video lessons. Test yourself. Answer the Week 2 learning task in your Google Classroom. Your task is to identify the similarities and differences between plane, concave, and convex mirror by drawing or by making a Venn diagram. You can post this video to answer it now, or you can also do it later. Laws of reflection. Before we proceed, there are some terms that you need to know. I want you to rearrange these words. Welcome back. Let's try rearranging these words. The first word is reflection. The second word is incident ray. The third word is reflected ray. And the last word is normal line. Let's try to define each. When we talk about reflection, it is the bouncing off of light rays. The incident ray is a ray of light approaching the mirror, while the reflected ray is a ray of light which leaves the mirror. The normal line is an imaginary line that can be drawn perpendicular to the surface of the mirror. Here is an example. We have a flashlight that is pointed towards the mirror. So the light is reflected. The graphical representation for the incident ray is an arrow moving or pointing towards the mirror, while the graphical representation for the reflected ray is an arrow pointing away from the mirror. Now, the laws of reflection are the following. One, the incident ray, the reflected ray, and the normal line to the reflecting surface all lie in the same plane, and the angle of incidence is equal to the angle of reflection. So as you can see here, the angle between the normal line and incident ray should be equal to the angle of the normal line and the reflected ray. So let's say the angle of incidence is a 25-degree angle. Therefore, the angle of reflection should also be 25 degrees. But there are certain exceptions to this rule based on the type of surface to which the light ray is being reflected as. The types of reflection. Now, there are two types of reflection, the specular or regular reflection and the diffuse or irregular reflection. Now, the specular reflection, this is the reflection of light on smooth surfaces, as shown in the picture. It usually follows the laws of reflection, while the diffuse irregular reflection is the reflection of light on rough surfaces, which somehow still follows the rule of reflection, but there is a variation. Now, an example of this is the image shown below. So on the smooth water surface, we can see clearly the surrounding, while the one with the wavy water surface, we cannot see clearly the surrounding area on the image projected by the water. Now, let's proceed with the qualitative characteristic of images formed by mirrors. The observed characteristic or the characteristics to be observed in ray diagramming are the following. The location, which is behind the mirror or the same side of the object. Now, the location can also be identified by other terms. But in this case, we're just going to use behind the mirror and same side of the object for now. O, the orientation. The image could either be inverted, it is upside down, or upright. S, or size. The image could become bigger, same size, or smaller. Number 4 is the type. The image reflected could either be real or virtual. Now, how do we differentiate between the two? First, a real image is formed when light rays actually meet after the reflection, and the image is inverted with respect to the object. While a virtual image is formed when light rays do not intersect after reflection, but they appear to diverge from the mirror, and a virtual image is with respect to the object. But for me, the easiest way to determine if it's real or virtual is that if the location is the same side of the object, then it is a real image. But if the image is shown or made or projected behind the mirror, then it is most likely a virtual image. You can also look at the orientation to determine if it's a real or virtual image. An inverted image is usually a real image, while an upright image is a virtual image. I want you to try this. Go and stand in front of a mirror and do the following. Number 1, I want you to stand in front of the plane mirror and see if the size of your reflection or your image is the same as you. Second, I want you to raise your left hand. Now look at your reflection. Which hand does your reflection raise? And last, is your image upright or upside down? Let's try answering everything. So I hope you did this experiment at your home. So number 1, the answer should be yes, you have the same size. You are the same size as your image or your reflection. Second, as you raise your left hand, your reflection raises his right hand. And of course, your image should be upright. Now, I want you to look at the picture below. What is in the picture? And why is it that the word ambulance written that way? Let's try answering it now. The picture shown is a picture of an ambulance. Now, why is it that the ambulance written in a reverse order? The answer is the word ambulance is written in reverse so that the driver in front using the car's mirror can read the normal orientation of the word. We have to remember that upon looking in a plane mirror, there is a left-right reversal, meaning what seems to be on your left side is on the right side, while what seems to be on the right side is shown to be on the left side when you look at a mirror. Now, the ray diagram and image formation of a plane mirror. So let's try. The location of the image formed is behind the mirror, while the orientation is upright. The size should be same, and the type is virtual. So as you can see here in the image, we have the object on the left and the image on the right, or the reflection on the right. You can see that the image is on behind the mirror. It is upright. It is the same size as the object, and it is a virtual image because one, it is behind the mirror. Two, it is upright, and three, they are practically the same size. Next is the following or additional description. Now, you must remember that there is a left-right reversal. And if you look at the image of the two guys here, the object has his right foot forward, while the image or his reflection has its left foot forward. So that is the left-right reversal. Now, let's try the ray diagram and image formation for curved mirrors. So what is ray diagramming? What is the purpose of ray diagramming? Now, ray diagram help us trace the path of light for the person to view a point on the image of an object. So it shows the path of light through the use of an arrow. Now, ray diagram uses line with arrows to represent the incident ray and the reflected ray. So there are some important points when doing ray diagram. Some call this as the anatomy of ray diagrams. So first is we have the principal axis. It is the straight line passing through the center of the curvature of the mirror. So you can see here, you can see it on the picture on the right. Next is the vertex, where it is the point where the principal axis meets the mirror, and the center of curvature, the center of the sphere whose surface forms the curved mirror. It is sometimes referred to as R, or the radius itself. And last is the focal point. It is where the light rays meet. It is usually between C and B, or it is half of the radius. Now, these are the following rays. So as you can see here, we have PF, we have the following rays to trace. We have the PF ray, so it is a light ray from the object parallel to the principal axis reflected by the mirror towards the focus. So let's try rewinding the GIF. So you have your line from the top of your object hitting the mirror, then passing through the F, or the focus. The next is the FP ray. So as you can see here, from the top or tip of the object, it goes first to the focus point, then it hits the mirror, then reflected back as a parallel line. Next is the CC ray. It's a light ray passing through the center of the curvature and it's reflected back along its own path. So as you can see, from the tip of the object, it passes through the C, then goes back to C. Then last, we have the vertex ray or V ray. It is a light ray directed towards the vertex, reflected at an angle from the principal axis. So from the tip of the object, it hits the vertex and it is reflected at an angle equal to the incident ray. And next, is we have to determine the LOST or the image description. So first, try answering where is the location of the image, what is the orientation of the image, the size, and the type. So how do you do that? First, you need to look for the intersection. So where does all this line meet? And upon seeing the line, you are to draw from the principal axis towards that intersection. So try answering the LOST now. Let's try to answer it now. So the image should be around here. Were you able to get it correctly? So an image is drawn afterwards from the principal axis towards the intersection. So this is your image here. Now, I just want to clarify that the image shown here is made to be bigger, appear wider to make it easier for you to spot. But it should be the same width of the object. So let's try to determine the loss. Let's see if you're correct. These are the following. This is the orientation or the description. The location should be the same side of the object. It is between C and F. The orientation should be inverted as shown in the picture. The arrow becomes upside down. The size, if you were to place the image right beside the object, it is much smaller. And the type is real. It is real because first it is inverted and the image is also on the side of the object and the light rays here all intersects. Let's continue with the ray diagram for convex mirror. So as you can see here, the convex mirror is somehow different. In the PF ray, we can see that the light ray, particularly the incident ray, hits the mirror and then it's bounced off away from the mirror. We were able to establish that the dotted line is only a representation if the rays were to continue inside the mirror. So meaning the dotted lines here is only a representation of the rays, but it's not actually light rays. So let's continue using the same rays as the concave mirror. So we have the PF ray, then followed by the FP ray, the CC ray, and the V ray. So upon finishing drawing that diagram, I want you to determine where are the following rays intersect in order to determine the characteristic of the image form. Let's try showing where the image should be. Now, were you able to get it correctly? So let's try to determine the location, orientation, size, and type. Here is the characteristics. The location is behind the mirror, between the focus and the vertex. The orientation is upright since they are both standing, top to bottom, top to bottom. The size is a bit smaller and it is virtual because it is not the light rays that intersect, but only an graphical representation of the rays. Also, it is virtual because the intersection occurs behind the mirror. So that is how you draw ray diagram for concave and convex mirror. Now, I just want to give you a summary for all the characteristics for concave and convex mirror or loss. All you have to do is to determine if the object is located in the following, whether it is at infinity or farther than C or beyond C, at C or the center of curvature between C and F, at F between F and D. This is for the concave mirror. And you can see already the answer for their location, their orientation, image size, and type. Now, except for letter F, you have no image to be formed because there will be no intersection. As for convex, wherever you place your object, the answer will always be the same. The location in a convex mirror will always be between F and B. It will be upright. The image will be smaller and it is always virtual. Now, I want you to answer the week 2 learning task in your Google Classroom. And that's it for now. Thank you for listening.